Hello, my dear students. After a very long time, I am engaging the class to you people. Due to some vacation, I was not able to conduct the classes. So today in this video, I am going to discuss structure and bonding of xenon complex compounds like xenon difluoride, xenon tetrafluoride, and xenon trioxide. So let us see one by one. Before going to understand structure, you must able to write the electronic configuration because the bonding involves exchange of electron. For that, you must need to write its electronic configuration. So when we come to xenon, atomic number is 36 and its various configuration contains 5s2, 5p6 and 5d0. So this xenon, it is a noble gas, so it's highly stable due to its octet configuration. That means it is completely filled configuration. So this is the electronic configuration of xenon in the ground state. And you also know fluorine. Atomic number of fluorine is 9. And if you write the configuration of fluorine, so it has only one unpaired electron in 2pz orbitals. So it has only one unpaired electron. That's why it can only form one single bond. So this is the configuration of fluorine. So during bond formation, xenon undergo excited state. At that moment, one electron which is present in p orbital. So particularly, so pi pz orbital excited and go to the nearest orbit, the 5d orbit. So then these orbits undergo hybridization to form sp3 hybrid orbital, that is 5s2, 5p2, 5px2. So here one electron shift to nearest p orbital, so it undergo sp3d hybridization, that is one s orbital and 3p orbital and 1d orbital is involved in bonding. So here it forms only two bonds, but these lone pair electron affect to the geometry of the compound. That's why we have to consider the number of the non-bonding electrons also during hybridization. So it undergo sp3d hybridization. So two partially filled orbitals are present. To the partially filled orbital, the fluorine. Okay, here there are two fluorine are present and each fluorine possesses one unpaired electron. So these fluorine orbital overlap with hybrid orbitals of xenon to form two single xenon Fe bond. So this is how xenon difluoride takes place. So here xenon difluoride means xenon form only two bonds. That's why we need only two unpaired electron and only the 2pz electron so shift to 5d0 on the excitation. So this is how the bond formation takes place. Let us see its geometry. So usually, what we expect here is, due to presence of some lone pair electron, geometry must be affected. But here, geometry does not affected by the lone pair of electron. Why? Because these lone pair of electron occupy in a trigonal planar position. And these fluorine, one is above the plane and one is below the plane. So actually this is the geometry, linear. Okay, xenon difluoride is a linear molecule, but actually it is linear, but three lone pair of electrons are present at equatorial position. So these are present at equatorial position, and these are do not affect the geometry. So that's why it possesses linear in shape. The next molecule is xenon tetrafluoride. So write the configuration. If you write, the configuration becomes 5s2 and 5p6. Here there are 4 fluorine atoms are present. That's why xenon form 4 bonds. So in order to form 4 bonds, we need 4 orbitals. But here, there are no partially filled orbitals are present. After 5p, only 5d empty orbitals are there here. 5d empty orbitals are present here. So when this is the configuration in the ground state, during bond formation, when these xenon and fluorine comes together, it leads to repulsion. This repulsion is responsible for creating energy, and so that's why the valence electrons of xenon undergo excitation. So here in xenon, the 2py and 2pz orbitals, electron from these two orbital excite us to nearest empty d orbital, okay, to form 4 partially filled orbital. These 4 partially filled orbital and 2 lone pair electron undergo hybridization to form a 6 hybrid orbital. To form a 6 hybrid orbital. Dear students, if you want to learn the structure, you must write the electronic configuration along with me. Then only you can understand. So electronic configuration and where the electron goes, and how many partially filled orbitals and how many lone pair of electrons are present. So these things you have to keep it in mind while writing the configuration. So it undergo sp3d2 hybridization. So 1 s orbital and 3 p orbital and 2 orbital to form equal orbitals of equal energy. So these are called as hybrid orbital. So sp3d2 hybrid orbital. You just look at the diagram here. So to the partially filled orbitals of xenon, the partially filled fluorine. So there are 4 fluorine. Each fluorine possesses 1 orbital. So these 4 fluorine electrons overlap with partially filled orbitals of xenon to form 4 sigma bonds. It forms 4 sigma bonds with xenon. So this is the structure of xenon. You just see here in the xenon you can find that. So there are 2 non-bonded electron pairs are present. 2 non-bonded electron. So one is in s orbital, other one is p orbital. These non-bonded electrons pair occupy. So one is above the plane, another one is below the plane, and the 4 fluorine atom occupy the 4 corners of tetrahedral square plane. So that's why the geometry of xenon tetrafluoride is square planar. So here is an exceptional case is that in valence shell electron pair repulsion theory, we understood that if a covalent compound contains only sigma bond or sigma bond, it exhibits a regular geometry. If a coordination compound contains lone pair of electron, the lone pair of electron disturb the geometry. So it is going to attain irregular geometry. But these are the special cases. Even though they have lone pair electrons or non-bonding electron, they are going to give a regular geometry, because in this case these non-bonding electron occupy a symmetrical position, and these 4 occupy a square planar. Okay, they are occupy the end of each square plane. So that's why the geometry is square planar geometry. Here repulsion is minimum and repulsion is same on either side. Here also the four atoms present at equidistance to this lone pair of electron. So and to this one also. That's why they experience equal repulsion from both the lone pair of electron which is present above the plane and below the square plane. That's why it is going to exhibit a standard geometry, that is square planar geometry. Next compound is xenon trioxide. So you know the configuration of xenon and oxygen. Here each oxygen has two unpaired electrons. So each oxygen can form two bonds here. So here this is the configuration of xenon in the ground state. So 5s2 and 5p6. When xenon undergo excited state, here xenon has to form 6 bonds with oxygen because each oxygen can form 2 bonds. Totally there are 3 oxygens are there here. 3 into 2, 6. So 6 bonds are present. That's why 6 partially filled orbitals are required for the xenon. That's why here when xenon undergo excited state, all the electron which is present in the p orbital excited and shift to nearest d orbital. So this is the configuration of xenon in the excited state. But here and they undergo hybridization. They undergo sp3 d3 hybridization. So in this case what happened? So each oxygen possesses 2 electrons. So it can form 2 bonds. That is, so from each electron, from each oxygen, one electron form sigma bond and another electron form pi bond. If you just look at the structure of xenon here, so here xenon it is bonded with 3 oxygen. So 3 double bonds are present. Among 3 double bonds, one is sigma and another one is, so each xenon oxygen bond contain 1 sigma bond and 1 pi bond. Totally in a molecule, so 3 sigma bond and 3 pi bonds are present. So these sigma bonds are formed by overlapping of unpaired electrons of oxygen, and so this is axial overlapping. So the sigma and pi bond depends on the mode of overlapping. If it is undergo axial overlapping, it forms sigma bond. If it is undergo sideways overlapping, it forms pi bond. So totally there are 3 sigma bond and 3 pi bond are present in this molecule. And the expected geometry in this case is trigonal planar. That is, this is the expected geometry. So xenon must be present at the center of trigonal, and 3 oxygen should occupy 3 corners of this triangle. But due to presence of lone pair electron, due to presence of lone pair bond pair repulsion, so you must know the difference between lone pair and bond pair. So these are the electrons which is present in the valence orbital, last orbital, but these are involved in bond formation. That's why they are called as bond pair, and this is not involved in bond formation. That's why it is called as non-bonded electron or lone pair electron. So these lone pair electron, due to the lone pair of electron, lone pair bond pair repulsion, so instead of trigonal geometry, it is going to attain a pyramidal shape. So this is a pyramidal shape. Okay, so xenon which is present here and oxygen which is present at the corners of the pyramid. So pyramidal shape instead of regular